episode of the Haptics Club podcast. I'm Eric from Razer, and I'm joined by my Haptic crew with Brian from SensorGlobe, Ashley from Titan, and Manu from Unity. The Haptics Club is a team of people that have a passion for haptics. Our goal is to raise awareness of the amazing tech and people in haptics and to foster interesting discussions on the subject. Joining us today, there is Dr. Ivan Poupyrev. It's an award-winning technology leader, scientist, and designer working at the cutting edge of interactive technologies. I still remember the Teslatouch paper before when I started my PhD on electrovibration, and I spent quite a lot of time on that. Ivan was the director of engineering at the technical project lead at Google's Advanced Technology and Projects division, where he focused on developing interaction technologies and products for future digital lifestyle. Prior to Google, he was the principal research scientist at the Walt Disney Imagineering research division and at the Sony Corporate Research laboratories in Tokyo. We'll start with a brief intro and then dive in the area of expertise and then in the future of haptics. We will, of course, cover challenges and opportunities of the haptic industry. Be sure to visit thehapticsclub.com and check out our latest blog post and peek into our upcoming guests. Last but not least, we will not be able to hear without our sponsor, like the Haptics Industry Forum, a haptics association which was created to streamline haptics standard and adoption, foster collaboration, and increase market awareness. Are you ready to talk haptics? Handing it off to you, Brian.
Thank you very much, Eric. Ivan, welcome to the Haptics Club. How are you doing?
I'm great. Thank you for inviting.
Good to hear. We're so happy that you're here. Can you share for the audience a little bit about your background and introduce yourself? Who are you?
So my name is Ivan. I just actually was at Google 6 months before. We left, the group of us left from Google, started our own company. We'll talk about later. And basically I spent my life kind of pushing the edge on a variety of interaction technologies. Haptics was one of them. And I spent all my life working basically in corporate research labs, more or less, in a variety of flavors. Like corporate research labs come, like many different flavors, like MMMs, I guess, different colors, many types of research labs. And I was in the Google has its own variety, and before that I was at Disney, which was also quite an interesting experience. And before that I was at Sony, and I worked in Japan for a long time, for about 15 years, working at the government research laboratories called ATAP, Advanced Telecommunication Research Institute. And I got my PhD from Hiroshima University, where I actually was working in virtual reality. So virtual reality, my starting point of the whole thing in the 90s, when virtual reality was very different from today's virtual reality. Today's virtual reality is something different. And before that, actually, I grew up in the Soviet Union, and I left Soviet Union right after, at the verge of collapse. The country was going to fall apart, and I grew up in Moscow. I studied mathematics, applied mathematics in Moscow Aerospace University, which kind of like leading university in Soviet Union, now Russia, for the aerospace engineering. So this is briefly what I'm doing, but I'm sure we can talk about more in through the lens of haptics, where I did in all those places.
For sure we will. What a track record. So for every episode, we ask our guests what their background is in haptics. So we also wanted to ask you, what is your haptics origin story? Where did it all start?
Haptics origin story. Let's see. I think haptics is obviously haptics, well experienced haptics is like asking like how people's vision stories start. When you start seeing the world, But when I started working with haptics as a field, was actually in Sony, right? When I was at Sony, and it was early 2000, I just finished my PhD in virtual reality. And, when I, actually maybe even before that, when I was doing my PhD in VR, which I was doing in collaboration with the Human Interface Technology Laboratory at the University of Washington. HIT Lab was one of the premium players for VR at those days. And, even in those days, like VR was pretty clunky, it's a big clunky, you just pretty much bunch of clunky boxes, you move them around in space. And the lack of sort of a physical interaction was always very, very apparent, right? The fact that you cannot touch things, the fact that you don't get feedback from virtual world, initially it's kind of accelerating when you go there, and it's like you kind of fly free, like in any way you do whatever you want. But it was very apparent. And actually kind of pushed me to leave VR as a field because I felt that experience is not there. And we started working with a group at the HIT Lab, which is Mark Billinghurst, who's right now in New Zealand, or maybe Australia, and Hirokazu Kato, who's in Japan, started working on the tool called AR Toolkit. I don't know if you guys familiar with AR Toolkit? Yeah, so I was kind of building AR Toolkit with those guys. Hirokazu Kato did all the tracking and first kind of like the marker-based AR alignment and tracking, and with Mark, and I was focused on interaction. And this was the first time when we kind of formulated the concept of AR talking as a tangible AR, where you, instead of using this AR object in space, and they just sort of like a version of VR overlapping the physical world, we had this concept where you have a physical handles for virtual objects, because you have a physical card, and a card you have a VR object, whether it's a character or something else, and you can actually physically manipulate it and having feedback from the plate that the object steps on. And we built the whole interface, actually doing this was collaborative work with Mercedes-Benz, and there's a video which built a project called Tiles, where we built the whole interaction concept, where you using these tiles to build this kind of physical interface, where every tile has a different, different interface object. So that was a starting point when I was thinking that how can we fuse visual feedback, audio feedback, and haptic feedback in one kind of cohesive interaction experience to really make this kind of virtual world as real as possible, right? And that's the starting point. But then, kind of when I went to Sony, I joined Sony Computer Science Laboratories with Jun Rikimoto, who is quite illustrious and famous interaction researcher. So then when we start really looking at haptics, and then that was like proper haptic work, like which you call haptics, because the haptics we did on AR was kind of passive haptics, right? You just move physical objects. Here in Sony, we did the first project where we actually actively actuating human skin. And we were, at that point, it was before iPhone, we started thinking about touchscreens, and like this idea, like, you have a touchscreen, amazing idea. And so instead of having a phone with the buttons and the click of the buttons and all this stuff, what if you had, like, that was my proposal, our proposal to our management, what if you have this like touchscreen and there's no buttons and everything is graphical and you interact with these gestures by moving your finger around? And the best feedback we got from the product division is that people will never ever accept a device without the phones because of the haptics. It's a stupid idea. Don't do that. And like now it sounds kind of like. Yeah?
What you're telling me that you could have prevented immersion from existing because you could have implemented the vibrotactile actuator inside.
We actually implemented.
Okay.
Yeah. We actually created.
It was the bottom. So there was the bottom the problem then. The bottom.
So no, these guys were like basically the product division people. They were like doing all this like remote controls and the mobile phones. So it's like people have a button and people love the button and people have haptic feedback. So you would never ever anybody going to use device with just a touchscreen, because when you press the graphical button, there is no feedback. And that's kind of switched our direction. Say, okay, well, let's figure out how we can build haptic feedback for touchscreens. And I kind of got in touch with this engineer, Shigeaki Murayama, who was engineer, sort of mechatronic division of Sony. And he said, let's build a new actuator which will slightly move touchscreen when you press the button, right? Like really, but you don't create vibration of the whole device like everybody else doing, but you just move the screen up and down very rapidly. It has to be very quick, and it has to fit in the device. And we started working the piezo actuators. We built this piezo actuator, and now obviously with the piezo actuators, it's a whole. So I can talk whole haptic hour about this whole story because it was kind of interesting. Piezo actuators, they're high voltage, right? The current is low, the voltage is high, right? And if you think about any mobile device, and that's what we're looking for mobile device for the phone to like have like touch screen only mobile phone. The voltage was at that time was a 5-volt voltage on the battery, right? So how can we reduce the voltage? And the current is less of a problem, but voltage was an issue. And so what we did there, we come up with this concept of multi-layer piezo actuators, because what happens there, as you're reducing thickness of the layers, the as you're adding more layers, you can spread the voltage across multiple layers. So you divide it. And so the more layers you have, the less voltage you have. So
I think the power hub from TDK is based on this concept exactly. They use multi-layer piezos specifically to reduce the required voltage for the. I think there is a product out. Yeah.
We did this like in the 90s, and then Sony has a key patents for that thing. By the way, they should take advantage of that. Which we wrote at that time. And then, so you split the levels, and then you create two layers, right? You have like top layer and the bottom layer. You have a layer in the middle, and then what's the benefit of voltage? Now, this is the problem there is that like you have a physical limitations on how many layers you can put, because if you if you keep adding layers, the whole thing becomes thicker and stiffer, and at some point, most of the force produced by layers is spent on bending the beam itself and not moving anything on top of that, right? So the trick there is not just to have multiple layers. The trick there is that you have overall thickness of device same. You cannot increase it, not just adding more layers, but you have to also, if you're doing bending mortar, how do they call them, bending piezo mortar. But the trick there is that like you have to make them thinner as you're adding more layers. And as you're adding them more thinner, if you go to manufacture, you said because it's baked layer by layer, like a cake, right? As you're adding more layers and as you're baking it, when they become thinner, in between those haptic layers, you have an electrode. An electrode is palladium alloy, but it's extremely high temperature. So even palladium alloy doesn't completely kind of goes and becomes liquid during this bending process. Still, it becomes kind of like sloppy enough, so the molecules of the palladium alloy goes in between palladium molecules of the piezo, because piezo is fundamentally a crystal combination, crystal past, and they start losing their piezo properties because it's become a mixture of elements. You need to keep them clean. So there's a physical limitations of manufacturing how a thing can go, right? So we went to this stuff. We built the factory line, and we actually shipped the product. Like we have remote control, which is remote control with which you can click the button and it's clear and you feel it. And it was incredible.
How is it called? Did you ship it in the market?
Yes, we shipped it in the market. It was it was before the iPhone. It was like early days. So
you don't remember the name?
Yeah. No, I remember. It's a Rex 7000, I think it was called, something like that. Sony Rex 7000. If you think it's search it for Rex 7000, you're going to find.
We will put it in the show note. Yeah.
Yeah, fantastic. So. Rex, the great device, it's fantastic. I mean, I loved it. And basically, what happens in those days is that you had this category of like product at that time for American market, by the way, where you have this super remote controls, a programmable remote control. It was a category of product for that, right? So like a remote control which can control everything in your house. And in Japan, people will say like, yeah, well, we don't have this product in Japan because in Japan houses are small, so you can pretty much turn on and turn off everything without leaving the couch. But in America, they have big houses and a lot of electronics, so they love their remote control. So we have the whole product for North America to sell this crazy remote control, which was programmable, right? Like with all the things. There was a website called the Remote Control Central, and you go to that Remote Control Central, the people discuss how they program their remote controls, and it was pretty impressive. I don't think it exists anymore. So because everything online now. So then so we shipped the product. Rex 7000 was on the market, and then we shipped also commercial product, which was editing station for the professional equipment for editing video for the Sony. And it was interesting thing we learned. The whole thing kind of collapsed when Sony had a kind of like Sony stock crashed around that time because for the first time they reported like negative results, something like that, and then the new management came and they started shutting down things which don't make money right away, left and right. So they kind of shut down this whole thing. And when they shut down, Apple came up with the iPhone, and there was like avalanche of interest toward us, like from all the companies, Nokia's and of the world, to like give us this, give us this. And all the project was shut down, so they give us they wanted to use this haptic feedback, but it was too late, unfortunately. So that's my origin story. It's a bit long, so
that's good. You were able to sneak in some fundamental physics inside, so I'm happy. So it was good. Thanks a lot. I think we can pass to the area of expertise. We're basically inside it there anyway, but I think it was a good origin story and a good say window over what is corporate research and also shipping products. And I think I want to start with the Teslatouch prototype or paper, which is probably one of your most cited haptics paper, which was this full wall of electrovibration that you could interact with. Can you explain, share with us how you came up with the concept, what was good, what was bad, and what happened otherwise?
Yeah, so we found it obviously by accident. Like a lot of good things. You don't like sit down there and one day and come up with electro vibrations. Ooh. And basically this effect you notice all the time, right? You have a computer, you touch it and you can feel it. Like you can experience electro vibration every time in often in your life, right? And it happens usually because the product is not grounded and there's a high voltage difference between the object you're touching and yourself, and there's a layer of insulated between you and object, and that's created sort of like attractive force, right? So we found it by accident, like everybody else. And since we were like, at that point, we were kind of like, it was like right away we were doing this touch engine thing. The thing's called touch engine, the previous one. There's also a paper, by the way, at UIST about touch engine. So like that paper should be more cited because it's actually quite interesting. And that the product. But we work on this upon the touch engine. And the problem with the haptics is they have to move things, right? It's like, this is like fundamental problem that haptic sensations come from physical displacement of neural endings in your skin, right? It has to be actuated somehow, right? And the fact that the mechanically move screen, when at the time we were building touch engine, it's just gigantic pain, yes, It's like, you have to think about how to move it and every small movement, so you cannot just glue everything. I said, everybody likes to glue stuff. You just glue things, the whole thing doesn't move ever, right? No, haptic doesn't work this way, right? If you glue things together, right? So you have to be free floating, how you mix it there, how you make sure that dust doesn't go. You have to think about dust seals, and then you have all the test scenarios, how you testing your product for reliability, drop test, the vibration test, they all go out of the window. You have to resign. Like this is a gigantic problem, right? So this mechanical vibration thing is really useless. So we discovered this effect. I think it was me. We said, this is really crazy. Like, where are these things coming from? Like, why these things happen, right? So I called my colleague at the time, who was working on Shigeaki Murayama at Sony. I showed to him that. I said, like, this is crazy. Like, look, there's no moving part. Obviously, this thing is not moving, but I feel this amazing feeling when I move the things.
Yeah, you were feeling the 50 hertz ripple from the grounded. That was
exactly. So it's like how can we do this thing? What we can do this thing? And so we started looking at this more deeply, and it was really kind of like, how to say, kind of mysterious thing, right? Mysterious thing, because we couldn't find any explanation anywhere. There was no papers. Nobody's looking at this. And then we keep digging, and then we found this paper like in the 50s, like in America, like published like a Scientific American something, or Americans or Science or something. I forgot this paper, like some 50s paper. And that happens when the electrification of America was happening. So people put in like electrical wires in the houses, and these guys discovered this effect that when you move your finger on an insulated wire, you have this effect. And they did all these experiments when they're like, oh, let's try to put a ladder, and I'll do it on the ladder, and I'm on the ground, like that. And they kind of were the first to say, like, and they called electro vibration, actually. They said, like, this is electro vibration. I think that's the term coming from them, where they basically said, formulated the fact that's like, look, this is because you have electrical attraction, static attraction force between things. And once we read it, and we had long arguments, I was hoping we have something more than that, maybe space force or something like this, I don't know. But it was as boring, just like, okay, electrical attraction between your finger and electrode. But then once we realized, well, then we can control it. So we said, let's control it, right? But that at that time, but then when this whole things fall apart, and then like whole changing feedback fall apart. My co-developer of haptics work in Sony was moved to like some division, like we have it's like, you know, in Japan when something they can move you like, you know, different places. So like one guy was moved like Hokkaido from Tokyo, so I've never seen him again. Like, and the other guy was like, say, okay, sorry man, I have to work on something else. And so I kind of put it aside, right? I said, okay, I'm not going to look at this anymore. And then I moved to Disney. And I found one topic. This electro vibration, we noticed it particularly very strongly on some type of 3M capacitive screen, single surface capacitive screen, right?
Yeah, with the ITO layer, with the and the
single touch. Yes, it was a silica. It's an ITO layer. The key point is single surface, which means like the entire screen. You cannot buy them anymore these days.
No, you need to make them. Yeah, you
need to make them, but that's why you could buy them, right? You just buy them. So when we do this haptic thing, we try to build a haptic feedback for VAIO computers. So we have them, and multitouch was not there at that point, like particularly, you know, available. But those were like, that was the touch key which goes into like, I don't know, to the vending machines in Japan, and which was going to the bank machines. So like, and so we're like, oh, this is like, and this one they gave amazing feedback. It's just amazing. It was such incredible quality. So we kind of set aside, and then when I went to Disney, in Disney Research, I said, like, I want to go back to that thing. I want to figure out, because I think in Disney you have a lot of experiences. You know, you can actually make something really, really cool. And yeah, so we started working on this stuff, and that's how this whole. And then we figure out there's a couple of tricks you need to know how to make it work properly, and there's a couple of tricks how to solve certain problems, right? So, but then that's how the whole thing developed. So I brought a couple of very talented people. Oliver Bohr, who is the first author on this paper, was a postdoc from France. He actually was my intern in Sony at the same time too. So even at that time, I started talking about this whole vibration. But then when I moved to Disney, he came over across to Disney. That's how we built Teslatouch.
That looks fantastic. Thanks for the second origin story. I think it's told from the mouth of the wolf. It's in Italian, and it's great to hear that. So, and then you work on electro vibration. You did work on vibrations before the screen in Sony. And did you continue to work on haptics in Disney Research, or were mostly interaction?
Yeah. No. I work on both of them, right? I think you cannot separate haptics from the interaction. Right.
Yeah, sure.
Haptic is an active sense, which means the perception of haptics is integrated sense coming from combination of different sensory stimuli, right? Coming from all sort of things, right? From vision, audio, your kinesthetic sense, your dynamic sense that you move your hands, all the muscles and skin being stretched and feeling of your joints and the sensation of your skin on the end of the finger. All of that get integrated to a single haptic experience, right? So we always were interested in haptics to create, particularly in Disney. Disney is an interesting company because, you know, like you work in Sony, well, Google for that reason, and then, you know, Sony makes things in millions, tens of millions, hundreds of millions, and each of them costs $10, or $100, and anything which is more expensive than $2, you never get in product. It's impossible. Right, so it's a massive pressure point, right? Like and the kind of funny thing, when I was in the 1990s, it was $2, and now I was working at Google, it's still $2. I'm like, guys, this inflation happens, okay? Like, why is it still $2? And like,
because you have a margins request from shareholders that goes up.
That's right. I mean, it's like people want more money, like it's still $2. Like, I mean, like you guys need to adjust to inflations. No, it's still $2. But you go Disney, right? And then this opposite model, right? They build one thing and it costs $100,000, but it has to work all the time. So they have a very crazy requirement for the reliability of everything they've built, because you have like one attraction, and it can cost whatever, $1 million if you want to, whatever. but maintenance would be like once every 3 years, and it's, you know, it works from 8 a.m. until 8 p.m., you know, like 3 minutes rides, like 1 minute to load, and it has to work like non-stop, you know, like, you know, for a month without maintenance, right? This kind of stuff, right? Anyway, but the point here is that like Disney is interesting because you can bring kind of a crazy experience like this in the products. And in Disney, almost anything you can come up with, there's something you can, somewhere you can use it, right? So like, because it's a massive like story talking land, right? Disney is all about storytelling, right? So you're going to come and say, it's like, hey, I come up with this talking stone. And somebody goes like, fantastic, that's exactly what I'm looking for. I was talking for looking stones, is going to hear, right? Give me a talking stone right away. And then, well, it's not as simple, but okay, that's sort of like how Disney works. Like you can sell any stupid, crazy, insane idea to somebody in Disney, right? So well, let's do this with let's do it with haptics, right? So the Teslatouch was one of them, but the Disney said like, look, we kind of like well, people don't touch much in Disney. Like, you know, they hate touch screens over there. Like touch screens is horrible, right? Because they don't like people going around with the phone, stick your face. They want to look around, you know, talk to Mickey Mouse and fairy dust and all that stuff. They use it like, you know, vending machine, sell tickets and all this crap they sell there, like all this merch as they call it. But overall, they don't care about touchscreens, but they do care about rides, right? They do care about you in the ride, having this experience of your life. And at that point, I started working with these guys in I don't know, have been in this, like there's Avatar Land. Have you heard about Avatar Land? There's Avatar Land, right? And so they bought the rights from James Cameron, and so it was pretty funny too. And I kind of got in friends with the people who were building this Avatar Land from the very beginning. So you know, it's kind of crazy. Like there's floating islands. There's like, you know, everything's in Navi, and Navi spelled opposite. If you spell Navi opposite, Navi is a language obviously in Avatar, right? If you know, there's Navi people and all that stuff. There's Navi language, fake language, which he came up. James Cameron came up. I met James Cameron. He was hanging out at that time. He was also having this bathyscaphe, this submarine he built to go like down to the ocean. So whenever he was not diving with in his submarine, he would come up with Disney and hang out with us. So these guys were like building this thing with the Navi people. And by the way, if you spell Navi opposite, it's going to be Ivan. So like, yeah, hi guys, look, you've got to get me involved in this project because
somehow you're there.
Yeah, I'm there. I'm there already from the very beginning. So we went there and they will build this attraction, right? Like you know, like the way Disney World built is a formula. It's like, this is not some random inspiration. It's just like it's a machine, right? It's a formula. And when you build the land, which is a piece of park, they have like number one attraction there, where they take all the money and goes to the land, cut it in half, and all this money to get this one mind-blowing attraction. And this mind-blowing attraction is this dragon flying, you know, like now you see that in a dragon, it flies around. And the head of the Disneyland of that time, he was like, look, I want you to feel this dragon, you know, it cannot be just like you sit there. You have to feel it's moving, it's breathing, you have to feel its heart beating and all this stuff. So, and at that time, we already started thinking about how can you use haptic illusion to create sort of continuous motion, right? And I was working with this guy called Ali Zarar, who is now working for TikTok, by the way, for the ByteDance.
Yeah.
And Ali was my other postdoc who was working on it. So like when I was saying, like, look, we need to understand, like, if you look at the haptic literature, people talk about haptic illusions, and they will talk about haptic illusions, and they will say, well, we found these illusions. That's amazing. This is great. Let's write a paper in Nature. And then everybody, like, you know, brushes their hands and move to the next thing, right? And I said, like, look, again, this is amazing because the fact you can create this motion, which means, what does it mean? They probably create like a phantom tactile sensation between two vibrators, right? It's incredible. Yeah. Which means, what does it mean? That means very simple, that you can create continuous haptic display with small number of vibrators. If you have a small number of vibrators, your cost of attraction goes down. If your cost of attraction goes down, your maintenance goes down. But it's more than that. if you have a seat in the ride, like the thing goes like this, or it's in some 60 motion platform, the weight and the resonance frequency of the whole structure is extremely important because it resonates, right? It's a physical thing. So whenever you put any weight inside of the device, the resonance frequency shifts, right? And by the way, majority of the rides, you'll be happy, Eric, to know, are made in Italy, and Disney does not make its own rides, and it buys them from Italy. Whenever you do something adding to this, again, the whole maintenance things moved around, all the calculations, all the playbooks which come from manufacturing have to be changed, right? So they hate adding stuff. It has to be very, very lightweight. So I said, like, look, guys, let's do them. So we started working on creating this. I said, like, we need to write an algorithm by taking 3 actuators. You should be placed a virtual actuator in the middle and be able to control it precisely. And that's what we started working on. And how to create a matrix, a rendering matrix where you have a sparse array of the actuators, but you can create a continuous motion within this array. And we built it. Like, we actually did study haptic sensation. We figured out how it works. We figured out exact curves of how to control vibration on both sides to move it up and down. We created this array, and it was actually amazing. Because particularly when you combine the visual feedback, where you have a screen and you draw a curve on the screen, and the whole vibration things move behind you. And when you have this 2 combination of visual and haptics, you really see the circle behind you. Like, it's just like the sensation was incredible. So yeah, we did this thing, and actually was shipped. Actually was on the ride. If you when it gets to the ride, it's kind of works. But I left when the ride was when actually work with the ride was happening. I already left to Google. But Ali finished it. I mean, the props to him. I mean, the guy is relentless, and he really believes in haptics. So he got this thing working. And if you go look at the pictures, at this ride, at the Avatar Land, and there's a photographs people taking. If you look at the seat, there's 4 circles. Okay, these are actuators which we built to create sensation of a heartbeat moving back and forward across the thing, right? Because as they vibrate, right, they push against skin or clothing and create a sort of like almost like visible marks where the actuators are. And we build these actuators actually. Like, this was also a whole story how we build them. It was also pretty funny because these are voice coil we found because again, cost, performance, reliability, this is all kind of issue. So this was one thing. And then when just another guy came over to me, Raj, his name is Raj, and he was a student from Illinois, and we wanted to build a air haptics. So you can stand somewhere, you can feel things happening to you, right? So you can game, you can push things. So we created a game. So we created a very precise control mechanism to control the, I don't know how, air vertex, right? You push the vertex and it flies around, right? Again, so been known for a long time. Everybody play with this. You can build by yourself, but how you can control it, right? How you can make it so it's reliably sends terrain. And enabling technology, by the way, which make it happen, was 3D printing, which was come out at the same time. Because when you do vertex, the most important thing is a nozzle design. And the way you design a nozzle would change exactly the physics of how things comes out. So we try to model it, this nozzle design, and the math is extremely complex, and you need to have like modeling tools and access to like mechanical modeling tools and simulation tools and liquid simulation and like all these flow control simulations. Like, these tools can cost like $100,000. We don't have it, so we just pretty much brute force it. Okay, we just like start printing these nozzles. We just buy like Edison making light bulb. Like, no physics, no understanding electricity. Who the hell knows how it is? Let's just change materials like as long as we can, right? So we just brute force the whole thing. And and we got it. It was a paper at SIGGRAPH, by the way. And I think it's I forgot what the name called. What is this thing? Okay, I remember. We'll come back. But there's a paper at SIGGRAPH which we presented at the conference. And it was very nice. It actually works really well. There's a very nice videos of how like the whole thing coming out, and that's my another. I think this was the last haptic project because I left to Google at that point, and I said like, okay, well, back to the corporate grind and building stuff which you can scale with multiple kind of things. So like see you guys later, haptic people.
Oh, I love that. Yeah, we're all feeling that deep in our bones. That's so much fun. So we've talked kind of about like some of the amazing past projects you've worked on. Let's look into the future, because of anyone, we want to know in your brain, where you see the future of like haptics, interactive technologies in say like the next 10 years, even 20 years. What does it look like? What are the things you're looking forward to? What do you want to see happen? Or you'd be cheesed.
I think it's a mistake to take haptics outside of the kind of overall experience about human-computer interaction, or where computing is going to in general, right? Because as I mentioned, I think the haptics is this integrated feeling which combines a variety of modalities, and it's very, very important. It's the biggest sensing organ, right? Like 2 square meters, like human surface space of the skin. So it's super important. And so I think when you think about the haptics, you need to see where the whole field's going to, right? That's what you're looking at, right? And just like a lot of work was affected when mobile phones came out. With touchscreen mobile phone, there's a lot of work stuff. Okay, well, how we do mobile things? When the watch came out, like these guys, I know them too, by the way, in Apple, who did the tactile feedback for the watch. Is that you cannot take it outside of the overall like mainstream where things are going. And I think where the things are going with the overall kind of like field of computing and interaction, generally spatial computing, right? And it's kind of this old idea, and people's going to be spatial computing, being like, it comes in different disguises and different names, ubiquitous computing, pervasive computing, ambient computing, augmented reality, virtual reality. But at the end of the day, it's spatial computing, right? It's the idea that information is not going to be on the device, like in the box, but kind of distributed in the space, right? And the importance of haptics is going to be very, 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 very high, I think, for this stuff. So once you start losing physical devices, you start coming to this thing where like how you can provide feedback, right? I actually did some work in haptics now thinking about it when I was at Google, because when we started working on, I did a project Soli, which we kind of invented the whole new area of sensing based on radars, millimeter wave radar called Solid. Our idea was to use a sort of this micro gestures. And one of the ideas of micro gestures is to provide feedback directly from the human body. So you can feel feedback from your own skin. So instead of like waving like this, but you do they do all the controls go through your body, becomes your own haptic feedback, right? So this was kind of important concept there. I'm a bit lost.
Let me maybe say something so that I think that this has been developed by Meta with the Neoelectric wrist that they are actually trying to do micro gesture reference with the skin, and of course Apple.
Yeah, it also happened. Yeah, but we built with the project Soli. We did it before that. Actually, we did it in 2000, I think 15-16. We announced this radar sensor we built, and the idea was if you look for Soli in my name, you will see all these pictures of doing these gestures like this. So the whole thing about micro gestures is I would say like there was a couple of papers before us, and I don't remember those papers, very few, but one and apart about the importance of those things. But we built the whole language and announced it. Again, there was a paper, SIGGRAPH, published about, I think 2016, there was a paper, SIGGRAPH, which at that time had a distinction of being second longest paper in the history of SIGGRAPH, by the way. Because we described this whole radar, how we built this whole radar, from the scratch, and because nobody knew what radar is about at that point. We actually have to explain the radar. So there's half the paper, basically textbook on the radars, and the other half how we actually make this radar and make it small enough to fit in the watch. And then the part of it is interaction language, right? Interaction language based on feeling on micro gestures. And then as we do this stuff, there is a Meta started picking up, and other people's up, and Apple recently brought it all the way to the finish line. But if you look, I think they know about this work, because when we published Soli and announced it on Google I/O in 2014, I've got a lot of inside info from Apple that they got super excited about this whole thing. Design team was like, oh, this is amazing. Because it's very natural. Anyway, so let's go about the future. So I think what Apple is building with the Vision Pro is sort of a glimpse where we're going to be going, right? I'm not sure if Vision Pro is the answer or maybe something else is going to be the answer. What's going to form we're going to take? But this idea that like you don't use touch screens but virtualization of the control, virtualization of information it's been happening for a long time. Like touch screens is a virtual interface, a virtual surface, right? They have everything stuff on the touch screen. It is a virtual reality already, but like taking the physical space is important. And the core technology which is going to make it happen is actually not just displays or not just haptics. The core technology is going to make it happen is going to be artificial intelligence. And that's why we left Google to start an AI company called Archetype AI. And the goal of the company is to build a foundation model which can ingest variety of sensor data and build comprehensive picture of the world and be able to then query this comprehensive picture of the world with a simple text queries or whatever call. But the goal there is to create uniform representation using like transformer models from a variety of sensors, right? And merge them, sensor fusion, kind of take it to the next level, and combined with world knowledge, which embedded into today's LLMs, right? And LLMs going to be, I think, going to commoditize. They're going to become like dime a dozen then at some point, and they're going to become better and more high quality, and then they will be given for free. This became a new tool for us, basically almost like an encyclopedia of the world. And by merging it with the sensing, we can actually start understanding what people are doing and predict what they want. And
but
then
are you looking mostly to interaction applications or general applications in other field? Because definitely what you're sharing as, if it's a general model, has many economical implications that probably are more economically viable or probably less complex than putting a human in the loop.
We're building a model, right? We're building one model which can, in a real time, reason about physical world based on a variety of sensor data in the real time, like as I mentioned before. And it's going to make both humans and machines to give them completely new level of understanding the reality and be able to affect the reality in like a planning course of action, best course of action, and make informed decisions, right? So we just want to push just like with ChatGPT, there was dramatic increase of quality of sort of like interaction between human and AI on the bot level. It just was it was a quantum leap in the quality, right? It was so sudden and for a lot of people, but it's incredible kind of like jump understanding. We want to achieve the same quantum leap of understanding physical world, right? Understand what's happening there, right? And you're completely right. There is if you build this kind of model which can do this kind of stuff, it's sort of like it's like a
ChatGPT, right? It's an engine that would power. Would power things. I mean, there is incredible applications like autonomous driving, robotics, production,
self-driving cars, smart cities, smart houses. Like it's a holy grail, right? So we kind of don't want to limit ourselves, but the interaction. But interaction is one of the directions we're looking at, right? And like whenever you build this platform, it's very like the danger with always building is kind of this big horizontal platform and just these models, the platform interaction models, is that any horizontal platform, it's very easy to boil the ocean and go nowhere, right? Because you don't know like where to go. So, and I've done it like all my work, all the haptics work I've done are platforms, right? I never did this, okay, I'm going to make this click thing. It's always like, okay, we're going to build a general capability and apply this particular problem, right? And then this particular problem going to inform you how to design technology in a way which is feasible to ship, right? So you don't create something which is completely out of question, right? Kind of like, but okay, you need to have an initial target in an anchor, right? So we're also anchoring our work now on this model, and we've been doing this for 2 months. We also anchor this work in a couple of real-time use cases, which kind of inform us. And spatial interaction is one of them, because it's coming actually from there's a lot of interest in that, right? A lot of interest in spatial interaction these days, because when you think of spatial interaction is coming from two directions, you have like like Apples of the world trying to kind of like change the interface. But you have like, like automotive companies, and you have air conditioning companies and smart TV companies, which want to change the way you interact with those devices, right? You want to make them, quote unquote, smarter, right? Mm. So we just yesterday announced our collaboration with Infineon, where we will together pilot our model for their sensors, right? So like when you have a cell, they have a very clear reason to do that, because they have like a portfolio of different sensors for industrial and home use, and they would like to provide the best experience for the people can have with those sensors, right? So like it means interpret them in the best possible way in combination with the other sensors, right? So that's kind of like example of the work we're doing. So spatial interaction is one of them, and you can have to start thinking about like how the haptics where the haptics would find the way there, right? And I believe that creating kind of this kind of generative haptic algorithms, right, which can generate haptic sensations depending on the like taking account entire situation in whatever with the use case with like mobile phone or in a room or in office, and generate haptic sensation at the right time at the right place, without you having to program every single preparation of different things. That I think is so it's generative. I think generative interaction is the way to go, including haptics, right?
Yeah, and that the problem always there, to look at the problem from a data science perspective, is the missing database. As that is, you don't have, at least compared to other types of market, the amount of available data to train your models is relatively limited or extremely verticalized for certain kinds of use cases. At least this is, besides, I mean, I know that D-Box is doing these things for cinema. They have probably the biggest database for haptics effects, for linear content, and they're extremely jealous about it.
Yeah, of course they don't share with anybody. Yeah, so these are challenges, but that's that I think, like in the hockey they would say that you don't go where the puck is now, you go where it's going to be, right?
No, of course, yeah.
So the same thing, like if you look at trajectory, talking about the future, if you look at trajectory where things going, I think. Kind of fusing kind of generative AI and haptics and fusing of generative AI and sensing and start thinking about like what does it mean for the haptics world. I think that's something people should start thinking now, and maybe like in 5-10 years you'll start seeing an example coming out.
And did you already raise money, or is just starting out?
We raised money. We established company in April 1st. And we working with I'm not going to disclose like details, but we raised initial pre-seed kind of money to get companies going, and we just turned the term sheet for the full seed round.
Congratulations!
So we kind of thank you. It's a market stuff, but it's kind of fun because like we with this sort of pre-seed small amount of money. I mean, if you have a focus, you can move very fast. So we really kind of build our own like visual understanding model, where you can like ChatGPT vision kind of alternative. Except ChatGPT vision obviously costs $1 billion to build and everything. We build it like for $30,000 with two guys that put it together, right? So, and it's not as good, but it's good enough. Right. It's good
enough to showcase the value, and then you build on top of that and you scale it, of course.
And not only that. I mean, it's good enough to build certain, but like, because if you think about like things with like all these AI models bring in, right? I mean, it's mind blowing. It's mind blowing. You can take a picture and ask us any questions about the picture you want, like are these people are happy or not happy, and it's like they're smiling, therefore they're happy. Like from our model, I get these answers, right? And then I take the same model, go around and home and say like, oh, this is a hole in the ground, or there's a bicycle helmet, there's a bridge, right? So this general understanding of the world, even very primitive, is absolutely incredible, right? Like it's just like we never had this tool before when we build interaction things, right? So even the level of super simple that we have, we can start building use cases, which is incredibly powerful. This is my intuition. And I don't think we need to go to the level of like, because they all go to the AGI, they talk about online world, they compete with the search. Like in the physical world, there's nothing, And it's just a bunch of handcrafted algorithms, like button presses and stuff, right? So it's incredible space. So I think haptics has to think about this way. And it's very now kind of like very early days and moves kind of changes very quickly. So I think it's important to have like for people to think where the thing is going to take us as we go forward.
Yeah, I mean that's absolutely fascinating because maybe there's this, let's say, trends right now are trying to think in AI, say, oh, it's not an overarching model the way, it's like specialized model that solve a restrained part of the problem, right? And this is partially, and right. Specifically for sensors, you are looking at things that are usually maybe less information intense than semantic words that have context, that have all these kind of, are much more complex, and not maybe so you are able to achieve extremely high performances with less data and less machine need. So maybe it's even on the edge, basically embedded into the sensor.
That's right. So, but I think this is like I don't know how we solve a problem. Like the biggest problem, of course, like how you can take these gigantic models, put them on the edge. What's the right way to do it, right? So, but And at this point, we have a couple of hypotheses how to build this. We haven't proven them, and there's multiple ways to approach this problem. But I think you need to think about not about the challenges you need to solve. You need to think about the prize at the end. And people are too much focusing on the how are we going to solve this problem? How are we going to solve this problem? But who cares? Like, I don't know how we solve this problem. We're going to solve it. But think what you're going to have when you solve it. If you can have on the edge a general understanding of physical world, right? You are way closer to AGI than any online bot model people are going to build, because you have a model which reads from physical world. It's like, like today's models, they learn about stuff in the physical world by reading messages from the people. It's like a person who grew up in a basement reading about the sun.
Yeah, it's a second order
in a book,
right? Yeah,
versus like actually, versus seeing the sun, right?
Yeah.
It's got a different experience, no? Like, it's a circle in the sky, with a kind of yellow and hot. Oh, I see. Does it look like a frying pan? Maybe not, So it's like you have to see things, and the same with AI. It has to see things, right? So anyway, so the price is amazingly high. So, but you're right. So the problem with verticalized solutions is always the same. You achieve a high performance in a very narrow domain. And that means, and it's expensive. To build these verticalized models is not cheap. It's a cost, money, and all stuff. And as the result, what happens, and I went through this many, many times, because the cost of building verticalized models is expensive, because they're not flexible for the particular use case, what happens? Everybody goes for the most common use cases. Everybody goes, the most common use cases are the most boring and unexciting. And not only that, there's a huge competition. Everybody rushing for the same thing, right? So now, how you compete when there's a competition against the things? You compete the dropping of the price. So it's it's a race to the bottom, and often the company which wins is not producing the best possible solution, but producing the cheapest solution which can go in one of those products. And because it's not best possible solutions, everybody takes it like, well, this haptics thing is kind of crappy, isn't it? Yeah, well, we don't need haptics. Let's remove it. Right, the first thing they do, and we save more money, by the way. Like, no, this shit is kind of crazy. Like, I don't like it, so it doesn't really work. And like, what is this? It costs $2. Like, let's cut down to and that's it, right? This is, this is a cycle, right? So
yeah, it's like I have this conversation every day.
Exactly. So and at some point you kind of need to break out of that sort of like horrible kind of like loop, like. And
that goes back to the quantum leap that you were saying, because if you enable, like ChatGPT, a different class of application with a foundational
single model,
model, building on a single model, so that other people can build application on top of that. Or I don't know your business model, what you want to do, but in general, that I would expect if you do the platform, you don't do the ecosystem, because otherwise you eat the lunch of the others. So you want to do the platform.
That's exactly the model. So it's not our business model is not we are not inventing the wheel here. Like the business model, very simple. We build the whole thing, give it to people. You need to focus on a few use cases, but that's exactly the model. Yes.
Yeah. But it should run. However, it should run on the edge. That's the whole point.
That's another thing. That's the question. So yes. So we can run on it has to run on the edge.
Yeah.
The question is, can you stream?
Yeah.
Is streaming enough? Right. Streaming, of course, it has to run on the edge, but can you stream?
Yeah, it's 100 millisecond latency. Okay. basically.
Yeah, it's
because
if
you can stream up, it's fine, and stream down, it's okay.
Yeah, because like I just also remember like we kind of get desynthesized how things move quickly, right, and how things change, right? But like when Netflix starts streaming 4K videos, because remember like when was it, like 2 years ago, 3 years ago, 4 years ago, like just 4 years ago, there was no 4K streaming, and then if you would tell me like 10 years ago that we're not going to use DVDs and CDs and not download the files, and going to stream in the real time 4K video on a screen in the room, I would find it hard to believe.
Isn't even there the new compression from Google, the AVI, right? That drops like 20% the requirements for bandwidth for high definition. Yeah, of course.
You know what I mean? So
yeah,
and then so this is, and I think that's also I was telling you, the economical cycle is also understood, right? Because the benefit of streaming, again, so you need to think about like the end benefits, because the benefit of streaming is so high, and be able to stream is so high. So it's naturally, by the nature of capitalism way of inventing, it attracts a lot of money to solve this problem. So now you have a gigantic amount of money trying to solve this problem, right? So it's going to be rapid commoditization. So that's why like network infrastructure and there's 5G and they're going to be like 6G and 10G at some point, and all that crap is going to be, and then there's like thousands of people trying to like fix a little bit of 20% here of compression, 20% here of like of that, So because it's a very easy problem to put money into, you know what I mean? Because now, after talking to venture capitalists, I kind of understand how they think. Like, okay, well, if I just put the money into this whole thing, and chip is going to be like 10% faster, I can clearly estimate like what's going to be the benefit of the market. I think again, this is flawed thinking in many ways, but that's how people think, right? So a lot of money will go these directions, but tons of money is going to be solving this whole thing. So that's going to be solved, streaming. And once you have a streaming, then
but there is a big challenge here that is there since forever. Reliability of wireless networks, which sucks, and it always sucks, and it's still sucking a lot. Which means that you are anyway tied to these types. Which doesn't mean that it's not going to work. It just means that you are
100%. Yeah. And the question is, how good is good enough? Right?
Exactly. That's the whole point.
Yeah. So how good is good enough? So the network reliability is network. Again, it's not good, but again, let's go back 10 years ago. We kind of get good to good. We quickly get used to good things,
Yeah, you're right.
It's like there's network terrible.
But in another way around, if you think about that, as human, we can infer the world with a really, really little data, really not a lot, and the image can be blurry, can be in the night, and you understand what's going on, right?
Yes.
And that also would in the direction which is, if your model is quantum leap forward, then you probably don't need enough information to infer what the heck is going on.
That's exactly the point why I think those models are absolutely critical for spatial computing, because you will never have the same sort of flexibility of input when you are on the go in spatial computing. You will never have a keyboard, right? You cannot, keyboard is a tool which allows you to explicitly communicate everything. You typing letter by letter. Like, how inefficient is that, right? It's crazy. You think about it. So you're not going to carry a keyboard with you, right? There was this guy, I remember, who did this, keyboard interface, and there's a bunch of people were doing like synthesizers using keyboard. This is going to happen, right? So, I think what happens there is that we will have to build for spatial computing to really take off. You have to infer people intent from very limited amount of information. So you have a very simple sensors which capture as few signals from your behavior and context, because our behavior is described by the context, fuse them together and convert it into a certain meaning. And that meaning will be communicated back to you in the form of, the output information, control, and so on and so forth, right? So this inference has to be done, cannot be done by a narrow single model. It's impossible. You really have to understand a lot about the world, what's happening on, understand, quote unquote, because most don't really understand, a lot of going on. And then with a small amount of information, you can interpolate and figure out what people want.
Yeah. Right? So let me rephrase it to be understand, because we are already capable to understand what the user does. There is a tracking or camera tracking. People more or less figure out the things. But what you're sharing is that if I have also a model of the world, and of course we as humans interact with the world, and what we do is by interacting with the world. That's why we behave like that. If I have a semantic understanding with the world, I can infer with much more accuracy what I am going to do and understand the semantic our intent, so I can predict better what I'm going to do, but specifically make the software, at least the content or the spatial computer system, react to your intent and read it with much more reliability. Am I correct?
Yes, because then you don't need to explicitly spell out everything you need to do. And if you don't need to explicitly spell out everything you need to do, you don't need to have complicated devices. You solve the problem with input, right?
Yeah.
And then the only thing you need to do is provide you what they're going to be, I think, provide, but similarly, can we provide a minimum amount of the output to you to confirm that the intent is correct? And I think haptics here could be one of the key functions. That's
one plays one role with video, with audio, with everything together as multisensory. Okay.
Right. So this is sort of like what we tried. Like this is kind of like we talked about this for many years. Like this is holy grail for spatial interaction for a long time. You know, like even when I was back at Sony like 20 years ago, we were making projects where you have like a single button and scroll bar and scroll kind of dial, and like, can we build this where it controls everything? You don't need to tell. It's just coming home, press it, and turns on light because it's you want to turn on light.
Things happen.
Or feed the dog, right? Or check children's homework, right? You don't have to do why do we have to explain everything? Like it's just so annoying. We're spending like more time interacting with the computers now and learning how to use them versus like anything else. This becomes a burden, right?
It's a concept of the perfect transparent interface, right? So.
Exactly. So that's our hope is to actually break this kind of dependency. But also, if you have this model, there's multiple use cases, multiple applications. So the question is like, again, the biggest question is like, how good is good enough, right? Like, because we don't want to like go too far because it's going to cost a lot of money. But like, what can be the lowest hanging fruit you can do with those things within the physical world, right? And that's kind of our first step.
Oh, Ivan, that's so brilliant, so exciting. We have so many more aspects we would love to chat about. So we're going to need to have you back on the Haptics Club.
Sure.
Before we do wrap up, we just want to give you the opportunity to tell people where they should learn more about what you're up to. Is there like a website they can check out? Where can they find you?
Yeah, so we have a new company website called Archetype AI.io. ArchetypeAI.com was taken. Cost a lot of money. But we have Archetype AI.io, and right now we're publishing stuff on Twitter at Physical AI. So we're trying to basically separate ourselves from the online world by saying like, look, this is the Physical AI. It's a different category of artificial intelligence. So we call it Physical AI on the Twitter, by Archetype AI, this company, and. Like my Twitter and my LinkedIn probably is the best places to find. So just put my name there and follow me, and I try to publish stuff which we're doing like pretty regularly. So now I don't have a PR department to control my communication. I can write whatever hell I want.
Oh, you heard it here, folks. You heard it here.
Well,
yeah, after many years, that's back to reality.
Yeah, it's really exciting, actually. That's super exciting. But yeah, thank you so much for joining us. This has been such a delightful episode for all of us. Like I said, we definitely want to have you back. There's so much more to discuss, and we look forward to seeing what you get up to with your team. That's exciting for everyone in the technology space. For anyone listening, you've got to check out the hapticsclub.com. Follow us on LinkedIn. We're on Twitter. Our blog is now live, so you can check out some awesome articles from your favorite hapticians. And of course, you can buy things like our shirt. I'm rocking the Haptics Club shirt. We'll have to get one for Ivan as well. But we've got more episodes coming up. Amazing guests like Ivan. The hapticsclub.com. We'll see you at the next episode.
Thank you. It was great talking to you guys.
Ivan, thanks for coming, and wish you the best of luck. And I will drop you a message if I come next time I'm in Silicon Valley.
Yeah, please do. You guys ping me, and if I don't reply, ping me again.
I know. I tried a few times and it worked.
I'm sorry for that. I'm just.
No, you don't have to say sorry. Life is complex. Thank you very much.
Yeah, thank you so much. We're really
great stories.
Have a good one. Bye.
Have a nice day, guys.